The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hi, and welcome back to the Learning Circuit. In a previous episode, we learned about the inner workings of a 555 timer. Today, we're going to look at how 555 timers work in circuits. There are thousands of uses for the 555 timer. That's what makes it so popular to use. But generally, it's used in one of three modes: astable, monostable, or bistable. The 555 timer, being a multi-vibrator, is a switching circuit designed to have 0, 1, or 2 stable output states. These states are astable, monostable, and bistable, respectively. In astable mode, the circuit generates a square wave. It automatically switches between two voltages without requiring an input signal or trigger. This state is often referred to as an oscillator. Think of it like a metronome ticking back and forth. It can have long ticks or short ticks, but either way, it continues to tick back and forth at the same pace without needing to be touched. In monostable mode, the circuit can be considered a one-shot timer, having only one stable output state. In this mode, a trigger causes the output signal to go high, where it will stay for a set period of time and then automatically reset low. It will stay low until activated again by the trigger. In bistable mode, there are two stable output states controlled by two triggers. One trigger can set the output high, while the other trigger can reset the output back to low. Set high, reset low. These are typically considered flip-flops. Before I show circuits that use the 555 timer in each of these modes, I want to review how the 555 works internally. A 555 timer has 8 pins. Pins 1 and 8 connect to ground and the supply voltage. They are connected by a voltage divider, which connects to comparator 1 with a voltage of 2/3 VCC and to comparator 2 with a voltage of 1/3 VCC. Pin 5, control voltage, can be used to manipulate that 2/3 VCC going to comparator 1. Pins 2 and 6, the trigger and threshold, are the second inputs of the comparators, which are used to set and reset an internal flip-flop. Pin 2 has to have a voltage lower than 1/3 VCC to set the flip-flop, making the output high. And pin 6 has to have a voltage higher than 2/3 VCC to reset the flip-flop, making the output low. The signal out of the flip-flop goes two places. 1, it is inverted and output to pin 3. 2, it controls a discharge transistor connected to pin 7. There is also pin 4, which can be used to reset the device. Since it is active low, pin 4 is typically connected to VCC. All right, let's get into our circuits. I'll start with bistable. In bistable mode, we need to be able to selectively set and reset the flip-flop. Here's one way to set up that circuit. First, how to set the flip-flop. We want comparator 2 to output low until it is triggered high. Trigger is therefore connected to VCC through a resistor holding it high. Then, a button connects the pin to ground. Any place there is a button in these circuits, it doesn't have to be an actual button or switch. It can be connected to some other kind of input as long as it completes that connection. Given that the path to ground has less resistance, when the button is pushed, pin 2 will be pulled low, changing the comparator output, which sets the 555 output high. When the button is released, pin 2 is pulled high and the comparator output switches back to low. The flip-flop and pin 3 outputs are unaffected. So we can set the output high. Now we need to be able to reset it back to low. There are multiple ways to configure a reset. One is to use the reset pin. This pin is active low. It connects to a transistor that keeps the flip-flop connected to VCC. If this connection is cut, the flip-flop will reset. Pin 4 gets wired similarly to the trigger. The pin is connected to VCC through a resistor, and is also connected to ground through a button. While connected to VCC with the switch open, the transistor is on and the 555 functions as normal. When the button is pressed, connecting pin 4 to ground, the transistor is turned off. The 555 output is reset to low. The second way to configure the reset would be to control the output of the comparator connected to threshold. Since we're not using the reset pin, we leave it connected to VCC. For this configuration, pin 6 is held low to ground through a resistor, and to VCC with a button. When the button is pressed, pin 6 is pulled high, above 2/3 VCC, so comparator 1 outputs high, resetting the flip-flop and the 555 outputs low. When the button is released, the pin is pulled low again and comparator 1 outputs low. Neither the flip-flop or 555 outputs change. So that was bistable mode. Let's look at monostable mode, where the output is set high, then automatically resets back to low after a predetermined time. The trigger can be configured the same way as in bistable mode. Pressing the button will trigger the output to set high. For the reset, we need to go over how the discharge pin works. The base of the transistor is connected to the output of the flip-flop. When the 555 output is low, on the other side of the inverter, the flip-flop output is high. This opens the transistor to let anything connected to the discharge pin be connected to ground. When the flip-flop is set, with the 555 outputting high and not Q outputting low, the transistor is turned off. So here's what we do. We connect the discharge pin to the threshold pin, then connect those to ground with a capacitor and VCC with a resistor. Here's what that does. When the 555 output is low, the transistor is on. This pulls the threshold pin and the capacitor to ground through the transistor. When the button is pressed to activate the trigger, the 555 outputs high, but the flip-flop output goes low, turning off the transistor. The capacitor, then connected to VCC, begins to charge up. When it charges to above 2/3 VCC, comparator 1 goes high and resets the flip-flop, resetting the 555 output to low. With the flip-flop output high, the transistor is turned on again, which allows the capacitor to quickly discharge towards zero. The entire circuit is back to where it was at the start and will be stable in this state until triggered again. The time it takes for the capacitor to charge up and reset the circuit can be controlled by changing the values of the resistor and capacitor. Here's the equation for calculating time. Using a 1000 microfarad capacitor and a 4.7 kiloohm resistor, the timer will last for about 5 seconds. Using a 100 microfarad capacitor and a 10 kiloohm resistor, the timer will last about 1 second. The last circuit to cover is using a 555 timer as an oscillator in astable mode. With this setup, the 555 timer requires no inputs, but will switch from high to low automatically. Let's see what that looks like. The buttons are gone, as this mode requires no manual inputs. The threshold and trigger are tied together. Discharge is connected to VCC by one resistor, and through a second resistor, it's tied to trigger and threshold. All 3 pins are connected to ground through a capacitor. Remember that trigger needs to go low to set the output high, and threshold has to go high to reset the output low. When the circuit is connected to power and ground, pins 2 and 6 take the path of least resistance and are pulled low to ground. That means reset is low and set is high, so output is high. Since not Q is low, the discharge transistor is off. The voltage source begins charging up the capacitor through the 2 resistors, so pins 2 and 6 will have a voltage equal to that of the capacitor. When the capacitor charges to more than 1/3 VCC, pin 2 pulls comparator 2 low. The capacitor continues to charge. When the capacitor charges to above 2/3 VCC, pin 2 triggers comparator 1 to output high, which resets the flip-flop. Pin 3 outputs low, and the discharge transistor turns on, allowing the capacitor to discharge through it. The voltage of the capacitor will discharge to below 1/3 VCC. This causes comparator 2 to go high, setting the flip-flop again, changing the outputs, which turns off the discharge transistor, and the capacitor begins charging again. The capacitor will continue charging to above 2/3 VCC and discharging to below 1/3 VCC, over and over, causing the output to flip-flop between high and low. So, to sum up our circuits, a 555 in bistable mode can be selectively triggered to output high or low. The inputs can be manually or digitally triggered. A 555 in monostable mode can be triggered high, and the combination of a resistor and capacitor determine how long it takes for the circuit to automatically reset back to low. And an astable circuit automatically switches between high and low. Again, the timing is controlled by the values of an external resistor and capacitor. Practical experience is one of the best ways to learn. So if you've used a 555 in a circuit, I'd love to have you post the schematics and tell us whether it's set up as monostable, astable, or bistable. If you haven't used one yet, find a schematic using a 555 and see if you can figure it out. Post about your projects and ideas on the Element 14 community on element14.com/thelearning circuit. Happy learning!